Hello everybody. In this video we're going to go over Unit 7, Big Idea 1, Trigonometric Functions. Our I can statements that go along with this big idea are I can use sine, cosine, tangent to find unknown side lengths and angles of right triangles. I can draw and label application problems involving right triangles to help solve. And I can apply inverse sine, inverse cosine, and inverse tangent to solve equations involving sine, cosine, and tangent. So that's our big idea we're going to be working on today. But the main purpose of this video is to show this document here. This document is called Solving Right Triangle, which basically means we're going to be solving for unknown side lengths and angles in right triangles. And this document is really going to help us organize our work by drawing a sketch of it, figuring out what we're solving for, figuring out what our known information is, figuring out what trig function we're going to use to solve it, and then actually doing the work to solve it. So doing this work here is going to organize our work for us so we can solve it a little more effectively. So best way to show how this document works is to use it, and you guys should have access to this as well. So if you want to print this out and follow along with the video, that would probably be helpful. My first right triangle I'm going to do right here. So I'm going to sketch it right here. This is going to be triangle like that there. In a right triangle, we always draw our little box for our right angle. I'm going to label this triangle A, B, C. I'm going to add one angle here. I know this is 40 degrees. I'm going to label this side here 7. And this, our hypotenuse, I'm just going to label that C, lowercase c. That's what we're going to be solving for. So this right triangle ABC, we have a 90-degree angle here, 40-degree angle here. We're given a side length 7 here, but we don't know the hypotenuse here. So let's go to our second column here. What are we solving for? I've mentioned that. We are not solving for an angle. We are not solving for the opposite side. We know that. The adjacent side, we don't know that, but we're not solving for that. We're going to be solving for the hypotenuse here. So I'm going to be circling right there. This is what we're solving for. The known information. Angle. Yes, we do know an angle. I gave you that information. And I also gave you this side length over here. This is the opposite side in respect to that angle. So I'm going to circle angle and opposite side. So what to use? So now we need to know which trig function to use, sine, cosine, or tangent. So we should know by now, hopefully you've learned enough about trigs so far that we know that sine uses opposite side and the hypotenuse. So in this case, we know the angle, we know the opposite side, we want to know the hypotenuse. So the sine function is going to help us here because we can plug in all these two things here and solve for the hypotenuse. So I'm going to just work over here. Our sine is equal to opposite over hypotenuse. This is kind of a reminder. Now I'm going to plug in my angle and my opposite side. So I'm going to use sine of 40 degrees is equal to the opposite side. We know the opposite side over here is 7 over our hypotenuse, which we've labeled C. So now we've set up an equation with one unknown, so we should be able to solve this. Now, in this case, we don't have C by itself, so we need to do a little bit of manipulation to get C by itself. In this case, I have 7 divided by C is equal to sine 40. So I'm going to rewrite this a little more user-friendly. So I'm going to rewrite this as sine of 40 degrees times our C is equal to 7. So I'm going to write this a little easier. Is sine 40 degrees times our value C equal to 7. Now it's a lot easier to get rid of this sine of 40 degrees by dividing it on both sides. This will cancel here. So my C is going to be equal to 7 divided by sine of 40 degrees. This is where we bring in our calculator. Always make sure you're in degree mode. So to get to degree mode, you hit mode, come down to radian or degree. We want to highlight degree, which I've done there. Then when we go back, when we plug in the number 40, it's going to automatically be in degree mode. So C, we'll go 7 divided by sine 40. Side length C is going to be 10.89. We'll put a little box around that. All right. So let's work on to another one now. Let's go for second one. Again, I'm going to sketch my right triangle. I'm going to do a different right triangle here. I'm going to still label it ABC. I'm still going to make C my right angle, but in this case, I'm going to make angle B 35 degrees. I'm going to make my hypotenuse 12. And the side I'm going to be solving for is going to be my adjacent side. I'm going to call that side A because it's opposite of angle A. So I'm going to be solving for side A. I know my hypotenuse and I know this angle B over here. So solving for, I'm not solving for an angle, I'm solving for one of these sides here. It's not the hypotenuse, I know that. It's either the opposite or adjacent side. So when I look at this angle here, I know this is the opposite and this is the adjacent. So I'm going to be solving for the adjacent side here. Known information. I know an angle and I know the hypotenuse. I do not know the opposite side, but I'm not really worried about that. What to use? I just realized I totally forgot to circle what to use in the first problem, and we use sine for that one, so I'm going to circle the sine up there. What to use here? Well, we know an angle, we know the hypotenuse, and we want to know the adjacent side. So adjacent side and hypotenuse, I know that that is the cosine function because cosine is equal to adjacent over hypotenuse. Hopefully we've learned enough trigs thus far that we have that down. So now we're going to solve for our adjacent side. We're going to use cosine of 35 degrees because that's our known angle. That's going to be equal to our adjacent side, which we have labeled as side A, over our hypotenuse, which is 12. Okay, now we have one equation, one unknown, so we should be able to solve this. We know that A divided by 12 is cosine of 35 degrees. So I'm going to rewrite this in an equation that's a little simpler. I know that cosine 35 degrees times my 12 will be equal to A. So I'm going to rewrite that as A is equal to cosine 35 degrees times my 12. This is where I'll need my calculator again. I'm already in degree mode. So I can type in cosine 35 times 12. Hit enter, and that should be my A value. 9.8. I'm going to round that 2 up to a 3 because there's a 9 there that rounds that up. So that is the length of the adjacent side. And I always like to look back at my triangle and make sure that makes sense. Just looking at this triangle, the hypotenuse is 12. And so this should be, somewhere around 10, just looking at it. If this number ended up being greater than 12, we know we're way off. Let's go to another one. This time I'm going to solve for an angle. Last two I've used sine and cosine to solve for a side length. This time I'm going to solve for an unknown angle. I'm going to start by sketching my right triangle again. Right over here. Just for fun, I'm going to call this triangle XYZ. I always label my right angle. This is going to be my hypotenuse. And I'm just going to give side length of 7 here and a side length 8 here. I'm not going to give the hypotenuse this time. And what we're going to do, we're going to solve for angle x. We do not know what angle x is, but we can use these two side lengths to figure out what angle x is. So solving for. I'm going to be solving for angle, and I'm just going to say angle x just because. The known information. I don't know any angles except for my right angle. The opposite side. I do know the opposite side in respect to angle x, and I do know the adjacent side in respect to angle x. So I do know this side length here, and I do know this side length here. I do not know my hypotenuse. So I'm going to circle opposite side I know, and adjacent side I know. So what trig function should we use? With opposite, adjacent, and I'm solving for an angle. So sine, cosine, and tangent. Tangent is the function that uses opposite and adjacent. So I'm going to circle the tangent here, because I know that tangent is equal to opposite over adjacent. So I'm going to set this equation up. Tangent, angle x, that's my unknown this time, is equal to opposite over adjacent. My opposite side is 8. My adjacent side is 7. Now I have one equation, one unknown, so I should be able to solve this. I need to get this x by itself. This is going to be x degrees something here. Somehow I need to get rid of this tangent to solve for this x. This is where we use our inverse trig functions. So what I'm going to do is use the inverse tangent function here and the inverse tangent function on both sides of the equation, of course, just to keep things equal. What inverse tangent does is it gets rid of this tangent here, kind of cancels it out to get this x by itself. So tangent, inverse tangent times our tangent function will get this x by itself. So x degrees is going to be equal to inverse tangent of the fraction 8 over 7. So now I'm going to go back to my calculator here. Inverse tangent is, you have to hit second and then pull up the tangent inverse. You can see it there. It's right on the tangent button, but it's the second option. So if I go second tangent and I do the fraction 8 over 7, then what it's going to give me is that degrees. So 48.81 degrees. That is going to be my degrees of angle x. And if I look back at my triangle here, that does make sense. It's a little bit more than a 45-degree angle there. One last problem we're going to do is going to be a word problem, actually. So this problem kind of aligns with this big idea, this I can statement here. I can draw and label application problems involving right triangles to help solve. So a lot of trig problems will be some sort of word problem where you have to draw the triangle correctly. And if you don't draw and label it correctly, you really have no chance of solving it. So our word problem today is going to be a 10-foot ladder is leaning against a house, creating a 55-degree angle between the ground and the ladder. How high up on the house is the top of the ladder? So we have a 10-foot ladder leaning against a house, making a 55-degree angle. And it's asking how high up the house that ladder is. So what I'm going to do is I got to sketch this correctly, because if I don't sketch it correctly, then I get really no chance in solving it. So I got a house here. I'm going to try to do a little sketch here. This is my ground here. So this is the ground. This is my house. I'll just label it with an H. I'm going to draw my ladder here. I'm just going to label it with an L. And I'm going to say that that's 10 feet because it's a 10-foot ladder. The other piece of information it gave us, we do know this is a right angle. And it also told us that the ladder makes a 55-degree angle with the ground. So right in here, this angle between the ground and the ladder is 55 degrees. That's what the problem told us. So now the problem asks for, what we're solving for, is how high up the house is that ladder. So it's asking for this side length right here. So what are we solving for in this triangle? We have a right triangle. We know the hypotenuse, that's the ladder. This would be our opposite side, right? The house. And the ground would be our adjacent side. So since we're solving how high up on the house it is, we are solving for the opposite side. What's the known information? Well, we know an angle, that's 55 degrees. And we know the hypotenuse, that's the ladder. So we know the angle, we know the hypotenuse. So when I have these circled, I have an angle, opposite, and a hypotenuse. The trig function uses opposite and hypotenuse as sine, right? So our sine, remember, is opposite over hypotenuse. And we know the hypotenuse, we know the angle, we need to know the opposite. So let's plug some things in. So sine of my 55 degree angle is going to be equal to the opposite, which is our h, we'll call that. I'm not confusing that with this h, which is the hypotenuse. This is the house, we'll call it. The house over the hypotenuse, which is L, which is the ladder. So that's 10 feet. So 55 degrees, sine of 55 degrees is equal to our house over our 10-foot ladder. In this case, we need to solve for the house, right? How high up on the house it is. So to rewrite this, I will have house is equal to sine 55 times my 10. And this is where I need my calculator. Sine 55 times 10 is 8.19. 8.19 is going to be our house. So look back at our problem. Does that make sense? This is like a 55 degree angle. That should be about 8. Should definitely be less than 10 because our hypotenuse is always our longest side. So yeah, that's how we use this worksheet here to help. All this stuff helps us organize our work so that we can solve more effectively. And that is it for this video. Thank you.